Hi everyone, welcome to learn the algorithm with me together. Today let's take a look at the 21 merge to sorted list and what kind of problem we need to solve. Now we'll be given the heads of two sorted linked lists, list 1 and list 2, and then we merge two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists and return the head of the merged linked list. So what it will look like? First, if we have the list 1, it will be like this. Like we have node 1 pointing to 2 and point to 4. And then also we have a list 2 is like 1, 3, and 4. And they are all sorted. That's what we already know, that they are sorted. But also we need to merge it as sorted as well. So how we sort it is also ascending order, right? And now like we have 1, 1, and 2, 3, 4, 4. This is what we expected. Like when we are merging. After merge, it will look like this. And how can we do that? First of all, I'm thinking that we should have a head node, right? So that I can return the head to our user. Oh, wait a minute. So probably we cannot have a head. Probably we have it's called a dummy node. Because the real head is the next one. So the next node, which should be. So I'm thinking that I will have like 2 pointers, or probably just use a pointer. It gives us like the L1 and L2, right? L1 and L2, the pointer it gives us. And now we are comparing these two nodes. So how we compare is like which one is smaller, and then we just connect it to the next node. So we have a dummy node, and also we need to have a current node to help us to keep track of the whole list. Now, if the L1's value is smaller than L2's value, we definitely do hope to connect. Yeah, so let's make it like we have a dummy node here. And here is the L1 node, and we also have a current node here. And then, like if L1 is smaller than L2, our current node definitely like pointed to the L1. Can use another color side, right? And that's what we're gonna do. Like the current node next should be the smaller one, right? And after that, what we're gonna do is remove the current pointer to our L1, right? Because we are getting ready for the next connection. So the current node will move to L1. And how about L1? It should be moved to the next node in the L1 linked list so that we can do another comparison. And L1 move to L1.next. And then now L2 is smaller than L1. And what we're gonna do is now current pointer is also connected to next. Is else if L L2 value is smaller than L1's value. And what we do is current the nest is moved to L2 now. Connect L2. And then it means that this is already disconnected now. And after we connected the current L to the L2, and we can also move the current pointer to L2, and then move the L2 to the next node in the L2 linked list. So the next step is current to L2, and L2 equals to L2's nest, right? And after doing that, we continue to do the comparison. And now the L1 is smaller than L3. So L1 so the current node will connect to the L1. So this will disconnect it. And then we move the current pointer to here, and L1 also move to next position. And we continue to do that. And now is L2 smaller than L1. We connect the here and disconnect this one. And we also move the current pointer to here and move the L2 to here. This is what we're gonna do. And then they are the same. So when they are equals, it's no matter, we just connect to L2 here. That's fun. So now L2 moved to non-pointer, which means that we have to stop, because if the L2 is pointing to a non-pointer, it cannot do the comparison with L1, right? So that means when we are doing this traversal, when we stop is while the L1 is not now, and L2 also not now too. So after that, if anyone still have the nodes, we still continue to connect it to this list, right? Because when we stop this looping, it doesn't mean the whole merging step comes to the end. So we also need to check if L1 is not now. It's not now, then the current nodes should continue to connect L1, right? The current node now is at the end of it. Or if L2 is not now, the current nodes also need to connect to L2. So this is the whole step how we solve this problem. And after all that, because we still have the dummy node here, so we can return the next node, which is exactly the head of the merged list. And what is the time complexity? So the time complexity should be because we traverse the two linked lists fully, so it should be the m plus n, and m is the length of the L1 and n is the length of the L2. And how about the space? Because we don't use any extra data structure, we just disconnected all this disconnected these links or reconnected it and use like dummy node and current node. So we can just think about like the constant. So this is how I solved this problem. And now let's move to the coding part. All right, and now we first have to have the dummy node here, new list node, and then we also have a current pointer pointed to the dummy node. And while the list 1 is not noun and list 2 is not noun, because any one of it are noun, we cannot compare their values, right? So now when they are not noun, we are start to do the comparison, like if the list 1's value is smaller than list 2's value, all right, it's list 2. Then what we do is the current pointers point to the list 1, and current pointer also move to the list 1 now, and the list 1 is moved to the next place. And else, if the list 2's value is smaller than list 1, what we're gonna do is we point it to the list 2, and then move the current pointer to list 2, and list 2's pointer also move a step. And after all doing this, we need to like check whether there are anything still, like any nodes are not connected to our result list. And if the list 1 is not noun, and then the current next will point it to the list 1. And if the list is the list 2, not noun, then our current pointer connected to the list 2. And after that, we are returning our result list, which is the dominoes nest. And that's it, and let's run it. Cool, so now the test case has passed, and yeah, so even though those lists are now, that'd be great, and we can continue to just return it. All right, so now let's submit it. Great. And this is how we solve the merge linked list. And we will use a dummy node to remember which is our result. And also we use a current pointer to help us to keep track of like which position we are working on. And I believe that will help us to solve the related problem. So if you think this video helped you, please give me a thumbs up. That would be great encouragement for me. And thanks for watching. See you at next video. Bye.